Hi, welcome to Atomic Structure 1 on element notation. My name is Dr. English, and today specifically we're going to look at the topics of how to write an element symbol, atomic number, and a little bit of practice at the end. So the first thing that we're going to look at is how to correctly write an element symbol. Now, for convenience, chemical elements have abbreviations called element symbols. And element symbols, which is how we represent all of our elements on your periodic table, consist of either one or two letters, unless they're one of the unnamed elements, which are basically composed of three letters, and you might see them at the end of your periodic tables, something like, oh, I don't know, U, 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 or another option might be U, U, B. These are unnamed elements whose names are still to be determined. Now, when you write these element symbols, the first thing that you have to remember is that the first letter is always capitalized, and the second letter, if there is one, and sometimes there is and sometimes there isn't, but if there is a second letter, it is never capitalized. So let's look at two examples, the first one being boron, which is a capital B, and calcium, which is a capital C and lowercase a. Now, to find the element symbol in your reference tables, you go to the periodic table, and if you look at the key at the top of your periodic table, you'll see the letter C, which is capitalized and representing carbon, and then next to it, it even says symbol. Now, you might be asking yourself, okay, that's nice, they gave me a symbol, but how do I know the name that goes along with that? To find that particular piece of information, you would want to go and look at Table S. Table S will list all of the element names and their associated symbols, which really is quite handy. Now let's talk about atomic number. An atomic number is going to represent the number of protons in the nucleus, and we just talked about in the last tutorial about protons, that they're positive, they're equal to 1 atomic mass unit, they're about the same mass as a neutron, and again, they're found in the nucleus. The atomic number of an atom will always be equal to that number of protons. For a particular element, the atomic number represents the number of protons found in each atom of that element. An element's chemical identity is based on the number of protons each atom contains. If you change the number of protons, then you change the identity of the atom. And that's a really important statement right there. So let's say it one more time. If you change the number of protons, then you change the identity of the atom. So we really cannot mess with the number of protons inside the nucleus of an atom unless we want to change it, which might be the case, especially if we talk about something down the road like in nuclear chemistry. Let's look at two examples. Here's an example of magnesium. Here's the symbol for magnesium, an uppercase M and a lowercase g. So the atomic number would be 12. Therefore, the number of protons will be 12. And we can see it represented right here on your reference table. Let's look at another example. Sulfur. Sulfur is represented by a capital S. The atomic number is 16, therefore the number of protons in each atom of sulfur would also be 16. Now let's try some practice. So here's what I would like you to do. Either in your notes or if you're practicing on a separate sheet of paper, what I'd like you to do is there are 6 elements right here: potassium, zinc, iron, tin, phosphorus, and bromine. What I'd like you to do is to use your reference table, look up the symbol for each, find the atomic number, and figure out the number of protons for each atom of the element. So stop the video, and when you're done, start it again. Welcome back. Now you can check your work. So if we have potassium, the symbol for potassium is K. The atomic number is 19. Therefore, the number of protons will be 19. For zinc, the symbol is Zn. The atomic number is 30. Therefore, the number of protons must be 30. For iron, iron is Fe. The atomic number is 26. Therefore, the number of protons must be 26. I think we can see a trend here. Tin, the symbol for tin is Sn. The atomic number is 50. Therefore, the number of protons is 50. Phosphorus, the symbol for phosphorus is P. The atomic number is 15, therefore the number of protons must be 15. And finally, bromine. The symbol for bromine is Br. The atomic number is 35, therefore the number of protons must be, you guessed it, 35. So the big thing that we're walking away from this tutorial with is that the atomic number will always equal the number of protons. So what did we learn in this little tutorial? Well, we went over how to write an element symbol, we looked at the concept of atomic number, and finally we did some practice at the end to just reinforce that concept. Need more help? Please feel free to contact me. Hope this helped. Have a great day.